Welcome to this SOS video on exponential relationships that can be represented symbolically. So as a reminder with your vocabulary, your initial value is a starting point of a function when the input equals 0. So we're looking at the y-intercept when you graph it. The common ratio or factor is the value that will be raised to a power. We call it factor because that number is going to be multiplied a number of times depending on the power. So exponential relationships increase or decrease very rapidly. The common ratio, or our factor, is the number multiplied one term to create the next term. When we write a function rule that represents an exponential relationship, we first find the initial value, a. That's the value for y when x equals 0. Then you find the common ratio b. Take the value of one term and divide it by the previous term, just like we did it in a geometric sequence. And then you substitute those values in f of x equals a b to the x power. All right, let's try that with a few practice problems. You were asked to write an exponential function in the form of k of n equals ab to the n power that models the table of values below. So when I take a look at this, I can find my common ratio if I take any term and I divide it by the previous one. So let's try that. We're going to have 4,131 divided by the previous term, 1,377, and I get 3. Let's try that with another number. 459 divided by the previous term, 153, and I get 3. And if I did that a number of times, I would still get 3. So my common ratio is 3. We're going to call that's actually my b. My common ratio is my b. So this is common ratio. Now the other value that I need is my a term. My a term is my initial value, which is when x is 0. But I don't have that. I just have the second term and so on. So not only do I need to find my first term, I need to find my 0th term. Well, how do I do that? So to get to each of these next terms, I multiply by 3, and I multiply by 3, and I multiply by 3. If I'm going to go backwards, instead of multiplying by 3, I'll do the inverse. So to go backwards, 459 divided by my common ratio is 153. So to go backwards, I'm going to divide by 3. So to get my first term, I'm going to take 153 and divide it by 3. And that's 51. But I don't need my first term, I need my initial term, my 0th term. So I'm going to take the 51 and I'm going to divide that by 3. And I get 17. So my initial term was 17. So now I have my a value is 17, my b value is 3. I look in my table of values to make sure I'm using those variables. So I say k of n equals my a value, 17, times my common ratio, my b value, 3, to the n power. And remember, when you write an equation, you are going to want to check to make sure it works. So let's go to y equals. We're going to type in 17, the base is 3, to the n power, or x. And I'm going to look at my table of values and make sure it matches this. So my 0th term is 17. My first term is 51. Well, how about my 5th term? I go to my 5th term, and yep, it's 4,131. So I know my table of values matches this. That means my equation is correct. Okay, let's look at our next practice problem. A new comic book is introduced. Over time, it increases in value exponentially. That means I'm multiplying by a number each year that it increases. After 1 year, it's worth $5.10. So in 1 year, it was worth $5.10. After the second year, it was worth $6.12. So you're first asked to write an exponential function that represents a situation. Remember to define your variables. So let's set up a table. I can pick any variables I want. I'm going to use n and f of n. I don't know the 0th term. I don't know how much the comic book was when it was first sold. But after 1 year, I know it was worth $5.10. And after the second year, it was worth $6.12. So how do I figure out my 0th term? Take a look at the first problem, pause the video, see what you have to say. Okay, so to find our ratio b, we're going to take our first term. So this is to find b. We're going to take one term, so $6.12, and we're going to divide by the previous term. Those are the only ones I have. And I have a ratio of 1.2. Remember, you were told this increases in value exponentially. So we know we were looking for our common ratio. So to go to $5.10 to $6.12, we multiplied by 1.2. So to find my 0th term, I'm going to go backwards and divide by 1.2. So $5.10 divided by 1.2 gets us $4.25. So the comic book initially was $4.25. And write this as a reminder. To find A, we took the first term and we divided the first term by the ratio. So we said $5.10 divided by 1.2 to get the $4.25. Okay, remember to define your variables. So n is the number of years, and f of n is the value of the comic book. Each year, the comic book's value is increasing. And you were asked to write an exponential function for this. So we're going to use these variables. F of n, f sub n, equals my a value, which is 4.25, times my common ratio, which is 1.2, to the n power. Remember, you just wrote an equation, so you are going to make sure it works. Go to y equals, clear that, type in 4.25 times 1.2 to the x power, go to your table of values, and make sure that our first value, $5.10, our second value, $6.12. So we know your equation's correct. Okay, using your function rule, how much will the comic book be worth after 11 years? So years is my n value. You were just told n equals 13. So I'm going to take my equation, and wherever I see n, I'll replace it with 13. F sub 13, my 13th term, after 13 years, 4.25 times 1.2 to the 13th power. Grab your calculator. 4.25 times 1.2 to the 13th power. And we get this. Even though you weren't given rounding directions, remember, since we're talking money, we do need to round to the hundredths place. We only have 2 digits with money. So the next one to 7 is a 2. That's not enough to make this one more. So my answer is going to be $45.47. How many years have passed if the comic book is worth at least $100? So with an exponential equation, we're going to have to use your table of values. So since we don't have the algebra knowledge yet, to be able to solve this algebraically. So what you need to say is, I entered my equation in y equals, and here is the table of values. So we go to y equals. We already have our equation in there. We go to our table of values, and we look for when that comic book will be worth at least $100. Okay, getting closer. And finally, in the 18th year, it is over $100. So to show my table of values, I need to show the value before my answer and the value after. So since my answer is 18, I'm going to write 17, 94.291. 18, that was the first year it was over. And then showing that 19 is $135.78 if it still keeps on increasing exponentially. Okay, and you need to make sure that you have said what your correct answer is. So in 18 years, the comic book is worth at least $100. Okay, this SOS video has been about how exponential relationships can be represented symbolically.